Hello everyone in the audience. My name is Dr. Jussi Kasurinen. I'm an associate professor from Lappeenranta University of Technology. I'm presenting on this video my paper, Software Engineering Expectations, an explorative case study of 3 university courses at this workshop. Unfortunately, I can't be there due to personal reasons, but I agreed with the program chair that I can give you this video version of my presentation, since on this paper I am the sole author, so I'm also the only person who actually knows the insides and outsides of this paper. Anyway, let's get to the point, because we only have 10 minutes to do this. The idea on this paper is that software engineering as a discipline is huge. There's several things in the software engineering spectrum, from the concepts of very technical things of system programming or operating systems development, to the high-end abstract concepts of developing organizations and their processes and quality assurance. This also means that basically, if you say that you are a researcher on software engineering, it doesn't tell very much about what you actually do. But it also means that we have an identity problem. So how do we convince the master's and bachelor's level students to learn the fundamental aspects? What are the fundamental aspects, and how can we get them to get interested on the software engineering as a discipline, to stay on university, become researchers, become doctors and stuff in the future? So in this study, we observe 3 implementations of different courses focusing on software engineering methods. And by methods on this occasion, I mean the different fundamental aspects, such as the processes, how testing and quality assurance is done, and so on and so on. So the fundamental building blocks of things which we do in the software engineering. So the idea is to identify from the course feedback and performance statistics different approaches and recommendations on what works, and especially how software engineering courses should be constructed to promote student motivation and interests towards the discipline. Our observations on this were a bit surprising, actually. We came up with the observation that the students aren't very necessarily requiring the cutting-edge technology on their education. For example, enabling long-distance studies isn't the most important thing they are interested in, or the availability to use things on mobile platforms, but they actually require real-life applicability. And actually, the key issue and the major breakpoint on many things is the observed relevance of the materials. But let's go backwards a bit and see where we actually collected this information. Like I said, the software engineering is a vast discipline with varying areas of interest. There are a couple of ways or methods or models which describe what should be included in the software engineering as a discipline. The ACM IEEE curricula, software engineering, is probably the most applied model on this area in the world. It recommends that the discipline is approached by first introducing the different software process models, methods, and tools which are used to construct software, also design software and do quality assurance, and use the tools which are commonly applied in the actual real world. Well, of course, this is a given, but it also means that we have to stay relevant in the university and follow what the industry is doing. At the same time, when the industry is interested in what we are actually doing as researchers, to come up with new ideas on how to improve our the worker performance or software engineering quality, or create better, more approachable, usable, more detailed ways of doing something like software test automation, or these other things which are very technical stuff, in a sense that it's actually the constructs require things like artificial intelligence and ability to predict things in the future. Okay, so basically there are studies which say that the existing models aren't that good. There's also studies which say that the motivational aspects tend to fail for several reasons. Uh, but still, things like SWEPHD, Software Engineering Book of Knowledge, agrees with the ACM SE curriculum that these ways, for example, describing the models, tools, and stuff, is actually a way of how to approach teaching the software engineering to the undergraduates, bachelor's, and master's level students. For example, the ACM model defines 10 major categories for software engineering, like I said, on a vast array of different things, from computing essentials, computer science, operating system stuff, to the software security, quality, professional practices. For example, how to conduct ethical aspects, how to cover ethical aspects of software engineering, or how to make do teamwork, soft values, on which there's actually a separate paper on this workshop. Overall, we wanted to find out a couple of things. The research questions presented here are the fundamental aspect of what we wanted to know. How should the fundamental software engineering courses be taught to enable more interest towards the subject? And what are the current areas of interest for the student body in software engineering? This was approached by doing an exploratory case study. We applied the principles by Eisenhardt and did open codification on the qualitative data. We didn't have enough data to actually do something like grounded theory approach, where we would also do actual and selective coding and these sort of things, but we did open codification to sort of categorize the different open feedback we received from these courses. These three courses, like mentioned, were all about bachelor's or master's level software engineering education. We had a total of 68 students submitted responses to the end surveys, and of course we also gained the full completion metrics and course statistics for our use. On this slide, which probably isn't very legible unless you are sitting in the front row, we see that we had over 200 different students participating on these courses, but on the general level they were all pretty much ordinary university stuff. We had mandatory projects, we had separate exercise tasks, demo lectures. We also were using video lectures in addition of traditional approach, since this is something that enables the students to go back and do things at their own leisure instead of going to lectures and following a rigid timed schedules for their studies. Overall, these aren't very well, groundbreaking things. They are more or less ordinary courses. So in general, it could also be assumed that the feedback collected from here would be something that's more or less a generic ideas from the students on generic or normal ordinary software engineering courses. Of course, if we first look at the statistics, of course, there's always a couple of students who did nothing. About 10 to 20% of students just enroll to the course and drop out immediately. This is possible because, for example, in Finland, there's no fees, there's no system which would prevent this sort of approach. But in general, of those students who actually start the course, 75–80% tend to complete the course. And of course, the average grade from 1 to 5 hovers around 3, 2.5, 3.5, if the course is sufficiently difficult but not overtly not overtly complicated or doesn't have a too huge workload. On this particular paper, you should also observe that the course A hasn't actually ended yet. We have still exams left, so that's why the results seem a bit appalling. But but let's go to the actually interesting things. Our observations, more or less, which you can read from the paper itself, say that the students want to learn from real life applicable experiences. They want to learn about management and design of quality practices from these courses, actual testing work techniques, and do testing exercises with real software projects and source code, aka also meaning as that they want to do something with real applications, for example, from open source or public domain sources. On course B, the students also actually thought that the exercises were more important than lectures, that the exercises were the things that they were actually interested in, and the actual demo lectures where we were talking about real software and showing how real software, for example, can be reverse engineered or designed without actually coding, was considered more important than going through the lectures. Similarly, the project works were both considered more important. Finally, the students were also interestingly more like the video-based approaches much more than the face-to-face lecturing, of course, because they could retake the lecture if they didn't understand something, or they could select when they want to participate in the lecture. On the motivational aspects, interestingly, most of our students were actually interested in software engineering. So the motivation of why software engineering wasn't considered a huge problem in this case, since we actually had 19% of students saying that they are interested in the topics in general. 25% of respondents said that they are there mostly because they want to learn practical skills. And finally, interestingly, the students would have liked to have these courses graded based on their project work, not on the course exams or things like that. So they would like to get their grades from doing projects, and those projects would be graded instead of actually taking exams where you have to cram information into your cranium for a small amount of time, do the exam, and then forget everything that was said. On the negative feedback, and this is actually one of the most important observations on this paper, is that the students wanted to do things with current tools. If the course content or applied tools were obsolete or at least old-fashioned, the students lost motivation very quickly, regardless of actually what they were going through with the what they were actually doing on the course. So okay, so these open observations are here. They are also presented on the paper. So you should go through the paper itself because it also includes quotes from the students, quotes from the actual feedback, and more discussion over these results. Finally, these findings are actually the most important lesson learned from these feedback observations. Okay, the students expect practically applicable skills, whether it means new programming languages, development tools, or exercise transferable to real-life scenarios. This has already been said. The preferred way of learning software engineering discipline aims towards project and case exercises instead of simple programming tasks or theory and examinations, meaning that you should always be doing something with projects, larger things, applications, open source, that sort of stuff. And finally, the most problematic area observed was not the intrinsic motivation or general interest towards software engineering, but the impression that the taught materials were outdated and obsolete, making the learning effort meaningless. The students lose motivation if they get the feeling that this isn't going to help them in the future, so why should I actually even bother learning these things? So this also was interesting because this actually was somewhat different than we originally expected. The students actually do not voice concerns over the possibility for long-distance studies, but they were more critical towards grading methods, the relatively low importance of project assignments, and if they didn't feel like they are getting practical experience, they were very critical. So they don't care, well, didn't care about the ability to do things long distance or from home or at their own leisure if they were taught something that was practical about the industry and in a sense usable in their possible future employment or industry or their future research work. Uh, Finally, I'm going to skip ahead of a couple of these findings because I've gone through them already. The point here is that you actually should make something, keep the courses maintained. That's the actual key issue we found. Of course, this was just an exploratory case study from 3 courses, about 70 students, actually minority of the entire pool of participants, but still the surveys were voluntary and almost 1/3 of the students actually submitted something, so we consider this part of a success. But as in any cases, this was qualitative study, a quick case study on student feedback. So these are observations. They don't confirm more or less anything, but they are guidelines and something that you should look into your own revision work on university courses in the future work. Okay, that's my presentation. Of course, I can't take any questions today. I thank you for listening to this presentation, which already is 1 minute over time. But still, send me an email or ask Antti Knutas to provide my contact information if he's around there when this presentation is ending. Thank you very much for listening and have a nice rest of the workshop. Thank you.